Hello! In this tutorial I'll be showing you how to use tools at the command line to connect to remote machines, both to control the machines and to transfer data back and forth with your local workstation. As you can see, I'm using OS X, and although it's straightforward to do this in OS X, it's also there's no problem doing what I'm going to do in other operating systems like Linux or Windows. Essentially what you need is to find something like what I'm using here called Terminal, which I'm going to open. If it's not already sitting in your dock, you can find it through Finder. Just look for Terminal and it should show up. And this will launch a little command window here where we're going to be interfacing with the computer. For this particular demonstration, I'm going to want to use more than one of these at the same time, so I'm going to open up a new window, which I'll keep here over on the right. If you're using Linux, there should be something called Terminal that you can launch. Looks pretty similar to what I have on OS X. And if you're using Windows to complete this tutorial, then you're going to have to install some additional software. One thing that you might try is something called PuTTY, but I would actually recommend that you spend a bit of time and install the Cygwin X package. If you Google that, you should be able to find it. This is sort of like a Unix type set of tools that you can add to your Windows computer, and it has things like SSH built into it. And make sure that when you do the installation you actually use Cygwin X rather than Cygwin, because the X part includes some features that will be useful for plotting graphs and this type of thing. But for now we're going to stay with OS X, and I will show you how we're going to be connecting to the machine. Now, in order to do this, of course, you must have a machine that you can connect to, and it turns out that I already have one and I have a user account that's been set up. But if you don't have that, you need to find a Unix friend of yours or a Linux friend or an OS X or something, a machine that can take in the SSH and get the username, get the address of the machine. Otherwise, you'll have nothing to connect to. Step one of this process, as obvious as it may sound, is make sure that you're connected to the internet. Right now my Wi-Fi is lit up, so it claims that I'm talking to my router, but it's worthwhile just to make sure before you go on a long troubleshooting trip to make sure that you're connected to the internet. And the easiest way to do that, I find, is just to ping google.com. So ping is a command that sends a little network packet to Google, and if Google receives it, it'll respond back, yes, that it does, and you'll see the IP address for one of Google's servers. This is an indication, the fact that this is coming back to me like this, that I'm connected to the internet and I can see websites properly. So that's good. To clear this window, I'm going to hit Control-L, just so that it'll start fresh, and now I'm going to go ahead and connect to the machine. The first command that we're going to be using is SSH, so I'm going to type that in here, and on the machine that I'm using, there's an account where the account is just called username. Normally the account that I would connect to, the username that I like to use is iTamblin, but for demonstration here we'll just put username. So if your name is Jane Doe and someone created you a username J Doe like that, you would type J Doe here. And if your name was Frank Ocean and someone created the username Frank O for you, that's what you would type here. Okay, so SSH username, and now I'm going to use the @ symbol like in email, and the name of the machine. The particular machine that I'm going to be connecting to is called simulator.science.uoit.ca. Once I've typed it in, I hit enter, and I should see something like this. The authenticity of host, simulator.science.uoit.ca, can't be established. Mentions this RSA key fingerprint here. Are you sure you want to continue connecting? Here I'm going to type in yes, because I know this machine is okay. And at this point it's going to prompt me for my username. So I'm going to type in my password rather. So now I'm going to type in my password, and oh, I made a mistake typing in my password. What do? Well, if I hold the control button and then hit U, it'll wipe it out. You can't actually see anything that's going on here, but when I was typing my password, I typed it in incorrectly. So I hit Control U and I can start again. I hit enter, and fantastic. Everything worked properly, and I've been dropped into the machine. Depending on what machine you're using, you'll get different information that'll come up here. Sometimes a machine will just drop you directly to this command line here, and it won't seem like a whole lot happened. Other times it'll say welcome to Ubuntu, or whatever distribution that you're using. It might offer some help with some documentation. And in this particular one, it actually gives me some information about the machine itself. So here's its IP addresses. There's 108 processes that are running at the moment. The system load is 0, and so on. And apparently I have 453 packages to be updated, 22 of which are security updates. So apparently after I finish this tutorial, I'm going to be spending a bit of time updating this machine and restarting it. This is the first time that I've logged into this machine. So I don't expect there to be much in the directory here, but let's just check. I can use ls, and as expected, my home directory is empty. Okay, I'm not going to review Unix commands here. That's going to be done in a separate tutorial, but just to prove to you that everything is working properly, I can hit a couple here. So this is top. I can say, echo hello. This is just another Linux machine. The only thing that's fancy that I'm doing right now is I'm accessing this thing over the internet. As opposed to over here, the same commands work, echo hello, but now they're running on my local machine. Now, it's easy enough to type commands over here, but let's suppose that I want to take a file that I write on this machine here. So this is my local machine, and I want to transfer this file onto the remote machine. What do? To do that, we're going to use a different command, which is called scp. So to test scp, of course, we need to have a file that we can use. And the file that I'm going to use, we're going to make one right now. So let's just go into my YouTube directory. And I have from a previous tutorial something called dynamics.py. I'm going to transfer this file from my local machine onto my remote machine. And the command that I use is scopy, scp, and I'll just type it out for you right now. The syntax is scp, the name of the file, I'm trying to do mouse copy here. Okay, that worked terribly, so I'm going to select the file and just do the old school Control-C, Control-V, print it out. Scopy dynamics, username at simulator.science.uoit.ca, and then very importantly, I include a colon at the end of that. If I don't include a colon and I hit enter, it seems like something happened, but nothing transferred. Actually, what I did is I just created another file called this thing, which is very confusing if you're starting off in the beginning. So really make sure that when you do the command, you include the colon. Now I hit enter. As before with SSH, it's going to ask me for my password. I'll type in my password. And then I can see that something happened. So it lists the file, and it's a pretty small file, so you didn't really see this thing progress. But as it goes, it will show you what percentage of the data has transferred, what the transfer rate is, and what the time is. And in this case, because it's such a small file, it took less than 1 second, so you don't even see it. How do I know that it made it over there? Well, remember, over here, I'm connected into the machine by SSH. So let's have a look in the directory that I'm sitting in. I'm going to hit ls, and haha, the file is where I want it to be. So we have success. What about if I want to transfer something a little bit more sophisticated, like a directory? Let's make a directory. We'll call it example1. And why don't we let's copy this dynamics file into example1, and we'll call it something else so that we can see that it went there. Let's just name it monkey.py. I hit ls. Remember, this is my local machine. And now I have a directory called example1. If I go scopy example1 to username at simulator.science.uoit.ca, remembering to include the semicolon, or the colon rather, and I hit enter, it'll prompt me for my password. But then it'll come back with this complaint that example1 is not a regular file. And that's true. Example1 is a directory. When you transfer over a directory, you have to include an extra flag, and the extra flag is -r. So I type it out again. And by the way, if you're not familiar of how quickly I'm typing this out again, I'm using the up and down arrows. This is a feature that POSIX compliant operating systems all share. Very useful, especially if you make some sort of typo. So now I've typed it in with the R. It asks me for my password again. I type in my password, and let's go over to the remote machine, hit ls, and lo and behold, the directory has appeared. Great. So now I have the ability to transfer from my local machine to my remote machine. What about if I want to go the other direction? So to do that, let's create another directory. I'm going to copy example2 to say, or example1 rather, to example2. So now I have two directories. And let's say that I went into this and I moved monkey to another file called donkey.py, and then we'll say that I went into donkey and I deleted everything in there and I went hello. Okay, so I have a different file, donkey, and I want to move this whole directory, example2, back to my local machine. Again, I'm going to use scopy, but now that it's going to operate in a different direction than it was before. So I type out scp -r because I'm transferring a directory, but rather than list the directory name first, I'm going to list the machine name and point to a specific directory within the tree. Username at simulator.science.uoit.ca. I include a colon, and now I give the name of the directory. Now in this case, because of where this directory sits, i.e. right at the top of my home directory, all I have to do is give its name. I'll give you an example in a second where I look for a file that's a bit more buried in my directory tree. I hit enter. Oh, and I forgot something. The syntax and the way that scopy always works, the way that you should think about it, is it's always from here to here. This guy here. So from here to here. Which means in reverse, you read it the same way. It's from here to, and I didn't define where to was, so I'm going to use a period to mean which signifies my current directory. I hit enter, and of course I've made a typo, because that's what happens a lot, so I hit up, I go back, I fix it, I look at it, hope that it worked, I hit enter again. Alright, this seems positive. I'm going to type out my password, and now something has moved. So what was the thing that moved? I look, now I have this extra directory in here, which is example2. Let's go have a look inside example2, and there's donkey. Ah, perfect. And it contains the file that I expected it would have. The last thing that I'm going to show you here is I'm going to create a third directory called example3, and within example3 I'm going to make a subdirectory, which I'll call, I don't know, sub sandwich. We'll go into sub sandwich, and then we'll make a file which we'll call list, and these will be some ingredients that I want to have on my sandwich. I'm going to have some mustard, I want to have some pepper, I want to have some cheese, and so on. What I'm going to show you how to do next is how to pull this file list without the rest of this directory structure. I'll cd to my the directory that I was operating in, and now you can we can do those commands. So as before, I go scopy username at simulator.science.uoit.ca, and I'm going to type out the path to where this file is. So I highlight it on this machine, I copy, I paste, I type out list, and I hit 2 here. It prompts me for a password. The file transfers over, and I can see now list has been transferred here. Notice that I have now lost before, up until this point, I was basically recreating the directory structure on my local machine that I had on my remote machine. Now this list is actually sitting in a different spot within the tree of my local machine. If you're interested in keeping a local machine and a remote machine in sync, and sometimes people are interested in something like this, scopy is not the tool that you want to use. There's more advanced tools like rsync, or even better yet, if you're talking about files that you want to do version control, you should be using something like Git. scopy is great if you want to move directories or files back and forth, but not for maintaining directory structures. Thanks very much for your attention, and if you have any questions, feel free to post them in the comments.